So I'm going to pass on to Noah Petro, who is going to tell us about LRO and resources. So Noah, over to you.
All right. Can I get a comm check?
You can.
Oh, that's unfortunate. I think the talk would be
Yes, it
much
is.
better if I were muted. So I want to first of all thank Angela Stickle for helping me with this. Angela is our theme lead on volatiles and external interactions going forward in ESM5, and so a lot of this work is really thanks to her and her leadership of that subgroup within LRO. Let's go to the next slide. So one of the missions that was left off of Clive's list in the introduction, and not through any fault of his own, is LRO. We did just get awarded a 3-year extension starting in October of this year. And I wanted to use this opportunity to talk a little bit about not only what we have done for the community lately, but what we will be doing over the next 3 years. As a reminder, we've been now at the moon for over 13 years, generating the largest volume of planetary data any mission has ever accumulated. That's, of course, due in large part to the amazing images that we've gotten from our LRO camera, as well as our proximity to the Earth. And so with the suite of data, and you'll hear about thermal measurements of the moon and Paul Haynes talk later this morning. Of course, we've had our neutron instrument. We've had an unprecedented measurements of lunar topography, the UV spectra of the entire lunar surface, including areas in permanent shadow. We've measured the radiation environment thanks to Crater, and of course radar data as measured by mini-RF. So I wanted to highlight a recent paper by Holly Brown looking at the resource potential of lunar PSRs. It was in Icarus earlier this year, and if you use the QR code there, that'll take you to that paper. So we have this incredible volume of data, and we are both looking towards collecting new data going forward, but synthesizing what we have. And so let me do a little bit of that here today. Let's go to the next slide, please. So looking forward, what we're going to be doing next, at the left-hand slide is a figure illustrating our orbital history, starting from arriving at the moon 13 years ago, our effectively 2 years in a, quote, circular 50-kilometer orbit, and then that very prescient decision in 2011 to go back into our commissioning orbit, this quasi-stable orbit that allows us to minimize fuel use while remaining close to the moon. The close approach of the moon, the periapsis, that red line on the left, effectively has been over the South Pole the entire time. And so we've had this really incredible time over the last 13 years measuring the polar environments. Every orbit takes us over both poles. And so we have focused specifically on the South Pole now since 2011, but effectively since we got to the moon 13 years ago. Over the span of the next 3 years, our orbit will actually increase, will roughly be circular around a 100-kilometer orbit. One other feature of our orbit is that our inclination is drifting. Ever since the day we got to the moon, our inclination has been drifting away from the poles. While we started at about 90.5 degrees, we have now swept away from passing directly over the South Pole to now effectively passing over about 85, 86 degrees of latitude. Now, we cannot fix this. We cannot change that, but we can feature it. So if we go to our next slide, this shows kind of the effects of that, what we call the ring of fire. We collect a dense set of observations over the areas marked in red. Now, of course, this has been happening our entire time, so we're highlighting the data that we'll be collecting in ESM5 here. But remember, we have effectively red coverage from this ring of fire everywhere toward the pole. So we have this incredible volume of data for the polar regions, for the polar environments. In ESM5 specifically, we'll be passing over several key targets, including the areas of enhanced hydration over Cabeus crater. Now, what this means is effectively there will be periods of time where we will be passing over Cabeus on every single orbit, creating an incredibly high temporal coverage resolution data set over those areas. Early in LRO's mission, we might have passed over Cabeus once or twice a month. Now we're passing over it many times every day in certain configurations of our orbit. So one of the things I wanted to feature and ask the community for is, hey, let's look at targets. Let's talk about specific areas. And I think Cabeus with the Yellcross results becomes one of those most compelling areas to start synthesizing not only the data that LRO has collected, will collected, but of course the data that's going to be coming from our sister spacecraft that are marching their way to the moon. Let's go to the next slide, please. So just a subset of some of the key observations that we'll be talking about in ESM5. I mentioned Cabeus crater at left there. So again, we'll have this incredibly high temporal coverage. I think the Diviner instrument in particular will benefit some of the most from those repeated observations. We have some interesting looks at how areas coming out of shadow for the first time in several months or several years might react to illumination for the first time. As well as looking at some areas of ice stability in both the South and the North Pole as we get into this new orbital configuration. And so volatiles remains a key theme of LRO going forward, and I really look forward to the possibilities of interacting with this community at the next workshop, as I hope we focus on several key areas to do data synthesis. Let's go to the next slide, please. So what do we have? Okay, so at the left, I kind of walk through many of the types of data, and particularly how those data sets are going to be used later on in this workshop. And again, I hope that the community hasn't forgotten some of the things that we got so excited about 13 years ago, whether it's neutron data, thermal models for ice stability, and the coincident observations that all of the LRO data sets can provide, including the radar data, not only from LRO, but of course the radar data that was collected on Chandrayaan-1 with the mini-SAR experiment. And so, you know, as we're talking about the future data, let's not lose sight of the incredible amount of data that we've already collected to bring, pardon the pun, bring some light on onto the situation. Let's go to the next slide. One of the key questions about the data that was asked for this workshop is, you know, what key data sets are required. And you know, I thought very hard about, you know, one of the great things that LOLA does not only provides the topography that we need for understanding the lunar surface, but also it removes the tyranny of the sun for active albedo measurements. And that measurement by lunar flashlight mission will kind of leverage some of those insights that we've gained, including some of these very interesting areas of increased albedo near the South Pole. And so what I'd like to see for some of these upcoming missions is not, well, we need to look at the whole moon. We've identified key targets. I think we have a number of areas of interest. And so perhaps one of the things that can come out of this workshop is a definition of more areas that we should be looking at. Let's go to my last slide as I'm in my home stretch here. And it's data relevant. And one of the questions that was, how do we consolidate data? You know, LROC and LRO have supported the Lunar Quick Map capabilities. And this is just an example of the kind of things you can do where you say, well, let me see areas that are in Earth view that get more than a certain amount of sun and have ice stability of X, Y, and Z parameters. And so all of the data that we've collected are publicly available and accessible through this Quick Map facility. And I would ask that all future data providers do the same. And with 5 seconds to spare, I thank you for your time and attention.
Thanks very much, Noah. That wasn't your last slide. This one was, but thank you. We'll move on